Let's now today learn how to analyze a normal distribution here. Here, as you see, they collect the heights of adult American males that are approximately normally distributed with a mean of 69.5 inches. So the mean here is 69.5 and the standard deviation is 2.5. So you have to add 2.5, 72 plus 2.5, 74.5 plus 2.5, which is 77. And 69.5 minus 2.5 is 67. 67 minus 2.5 is 64.5. And 64.5 minus 2.5 is 62. You draw it. You draw the normal curve. You now represent the data or the percent under the curve. Now, the question is, what percent of adult American males are between 67 inches and 64.5? I mean between 67 and 64.5. So the percent here will be 3 or 34% plus 34% plus 13.5%, which is 68 plus 13.5. It will be 81.5 is a percent of adult American between 67 and 74.5. Is it clear?
Yes.
Now, in a group of 2,000 adult American males, about how many would you expect to be taller than 72 inches? I'm looking now at above 72. So here is 72, above 72. How did you find now the percent or the area above 72? Be careful. Don't say it is 13.5 plus 2.35 because as I told you, here we have an area that is unmeasurable. So to find the area above 72, since the area under the curve from the mean up to the end of the normal curve is 50%, so you have to subtract 50% minus 34. When you subtract them, you will find the area above the 72, which is 16%. So the percent here for the males and above 72, you have to tell me it is 16%. Now, but the question is how many? Since he asked me about how many, so you have to multiply the percent by a number of the males, which is 2,000. So 16% times 2,000 will be 320 males are above 72 inches. Is it clear? Okay. Now, as an example, if I'm asking you now, okay, let's see this one here. Okay, before that, here. If I'm asking you now, what is the percent of American adult that is their height is less than 72? How will you find it? I want now less than 72.
It's 50%.
Now we're going to count everything below 72.
So what's the final answer? Because I learned many answers. What's the final answer?
I'm still calculating it.
Oh, yeah, look.
Is it 84?
84. Okay, Haneen.
It's 3.85.
Yeah. How did you calculate it? Yes, Susan. How do you calculate it? How do you find it?
I really just added the numbers below 72.
Did you mean 34 plus 34 plus 13.5 plus 2.35?
Yeah.
Haneen.
I did the same.
I subtracted 16 from 100.
Yeah, you have, no, it's Susan and Haneen, be careful. Here you have a small number, but it's not written. So you can say, like Ragad, you can say 1 minus 16%, which is we found it here. But if we don't know it, if you don't know the 16%, you have to know that from the mean up to the end of the normal curve is 50% plus 34. So you will say 50 plus 34% is 84%.
Yeah, this is what I did.
Yeah, the same answer.
But when you told me that you add 2.35 plus 13.5 plus 34 plus 34.
No, I added it in my mind because I was so lazy and I didn't have a calculator. I said that this is 50% and then I'll add 34%.
Oh, that's okay. Oh, that's what I mean. In fact, I thought that you add 2.35 plus 13.5.
No, I know there was an unknown number there, but it's
okay,
it's
okay.
50%
Okay.
there.
No, that's okay. Thank you. So you have to add 50% plus 34. It would be 84. Right. If I told you now, like, what is the standard deviation? What is the percent that are greater than 74.5? Greater than 74.5.
It is a little bit more than 2.35%.
2.5.
But I think we need to like say 1 and then minus all the other numbers.
Yeah,
How do we
exactly. Yeah, bravo. You have to you say now we say that the area under the curve is 1 or 100. So 1 minus, I want this one here. So don't say it is 2.35. No, you have to say 1 minus 13.5 plus 34 plus 50. Here we have 50 plus 34 plus 13.5. So let's add 34 plus 50 plus 13.5. You get 97.5. 1 minus 97.5 is 2.5.
Teacher?
Yes?
Teacher, why don't we just say it's 2.35?
I told you here you have a small area that is, the small shaded area, that is, its area is unwritten. So the area under the curve above the mean here is, all of it is 0.5. So as you see here now, the area under the curve, under the mean is 0.5. But if you add 34 plus 13.5 plus 2.35, you will not get 50. You will get, let's add the numbers first, 99.7 divided by 2. You will get 49.85. So the area from 69.5 up to 77 is 49.85. So that's mean here you have an
Which is 50, right?
no, you didn't say no. Here you have a point, or you have a point 15. Okay, this point 15 here is a area for this small shape. Got it?
Yeah, thank you, teacher.
Now let's
So we're
solve
going
this.
to add them and minus this one that is greater than 75, right?
Sorry. Yeah, but here, if I told you now the area above 67 as an with the percent, I'm sorry, the area above 67, you have to add 34 plus 50%.
Plus what, teacher?
50%.
Okay, thank you, teacher.
Okay.
Teacher,
Now let's have this got it here.
teacher,
Yes.
can you go back?
Okay.
Teacher, what you did is that you added all the 50% and then you subtracted from 1.
For what? For this number 49.85.
Yeah.
Yeah. No, I from 50%. I told her that the area above the mean up to the end of the normal curve is 50%. So to know this small area here, you have to add 34 plus 13.5 plus 2.35. They will be 49.85. So then subtract 49.85 from 50%, you will find that it is 0.15.
Okay.
Okay.
Thank you.
Now let's go to got it 3. The scores on Algebra 2 final are approximately normal distributed with a mean of 150 and a standard deviation of 15. So in this question here, we have first to draw the normal curve. So let's have now as a line. Then in the middle here, we have 150. So here we have 150. Now, I want to draw the numbers above them with 3 standard deviation and under the mean with 3 standard deviation. So what we have to do, we have to add 150 plus 15. So let's put here 1 standard deviation, 2 standard deviation, and 3 standard deviation. 1 standard deviation, 2 standard deviation, and 3 standard deviation. Then 150 plus 15 is 165, which will be here. Then 165 plus 15 is 180. Plus 15, 195. This is for the numbers with above the mean. Now let's find the numbers less than the mean now. We said now 150 minus 15, which is 135. 135 minus 15, 120. And 120 minus 15 is 105. They are like this. These are now the mean, 1, 2, and 3 standard deviation. So this is the mean. This is 1 standard deviation. This is 2 standard deviation. And this is 3 standard deviation. 1, 2, and 3. Then let's contact now between these numbers here. Let's connect, sorry, between the numbers. So this is now our bell curve. This is the first step here. Now then, what is a percentage of the students who took the test scored above 180? So I want now to find a percentage of the students take the test above 180. So before that, sorry, let's label the numbers. Here we have 34%, 34%, 13.5, 13.5, 2.35, and 2.35. Now, what percentage of the students who took the test scored above 180? So let's solve A. I want the percentage above 180. What you have to do?
One
minus all the numbers below it.
180.
Oh
Yeah,
no,
exactly. Or shortest way.
50 minus 34 plus
Bravo.
30.
Yeah, you have to subtract 50% minus 34 plus 13.5. So they are 2.5%. This is above 180.
Teacher,
Yes.
we don't add 2.35 because this one is above, right? We will add the one that is down, the 2.35%.
Sorry, miss, can you repeat your question?
We will add just the ones that is like above, no, behind the 2.35, right? 2.35, why you didn't count it?
I rounded.
No, I mean, why we didn't count 2.35?
No, miss, I want this area. Okay. And as you see here, as I told you, it's open. So how can I find this shaded area? I subtract 0.5 minus this one. When you subtract 0.5 or 50% minus this 34 plus 13.5, you will find the area of the shaded region.
Oh, okay, thank you, teacher.
Yeah. B now. If 250 students took the final, approximately how many scored above 135? I want now first to find the percentage of who gets greater than 135. What you have to do first? What is the percent?
We're going to make 2.85 plus 13.5.
No.
50?
No. You have to subtract or to add 0.5 or 50, you can say, plus 34. Because I want now this area. I know that above the mean is 50% plus 34, you have them as 84%. It's different than 1 minus 2.35 plus 13.5. Now for this questions, for these questions, I want the number exactly. Like yesterday when I measure the numbers on the bars, on the bar graph, if you tell me it is 84 with 84.5, I told you both of them are correct. For these questions or for this type of questions, no. You have to give me the numbers exactly. So if you tell me like it is 84%, then since I'm talking about 250 students, so you have to multiply 84% times 250. Your answer must be 210. Now, if you told me that it is like like 13.5 plus 2.35, then minus 100. If you told me now it is 84.15, and then you multiply it by 250, your answer will be 2010.37 or something like this. Or I mean like the percent is 84.15. If your answer, or if the percentage that you find it 84.15, it will be false. It must be 84. Okay, here don't round it. Here I want the exactly number. If it is 84, write it as 84. If it is 84.25, write it as 84.25. Got it?
Yes.
Okay, now is it clear? Do you have any question here for this one, for how to analyze?
No, it's clear.
Okay. Let's now do this one here. This is number from number 23 to number up to 28. A normal distribution has a mean of 180 and a standard deviation of 110. So here, a mean is 100 and a standard deviation of 10. So you have to add 10 to the right. So there will be 110, 120, and 130. This is for the three standard deviation. Now let's put the numbers here, 90, 80, 70. So we have them as 90. Now, I want now the probability that a value selected at random is in the given in this interval. Let's start now with 80 to 100. Now, think about, please, I want to bring the charger.